Welcome to another Mathcast. In this episode, we're going to be taking a look at calculating the volume of a solid, but this time we're going to be rotating it around an axis other than the x or the y axis. In particular, we're going to be rotating around the line, in this case, x equal to -1. That's going to be the major difference in this problem than all the previous problems. So our axis of rotation here is vertical, and that's important, which means that this is going to behave like problems where we're asked to rotate around the y-axis. Now, the other thing that's interesting about this example from some of the previous videos is I say use the method of your choice. On your exam and on a lot of the work you do, I'm not going to tell you or specify which method to use because part of the learning process here is understanding some methods are better for certain situations than others. So let's go ahead and figure out the region that we're integrating over and see if we can't come up with the best possible way of answering this particular problem. So we're looking at the line y equal x squared, and we're bounded by y equals 0, x equals 0, and x equal 1. Well, if you put all those things together, that is this region, this small region right here that we're then going to switch over. So doing our rotation, we're going to end up with, a pretty interesting looking figure that's basically reflected across the line -1 and then rotated around. Well, we have choices here. If I went disk method, then a typical rectangle for disk method would be something like this. So if I rotate that, I get a washer, so this would end up being the washer method. The only problem with that is you notice that the right side is 1 and the left side is the line y equal x squared. If I went with Shell's method, then a typical rectangle for Shell's method would be vertical, and I would then have to rotate that around the line at x equal to -1 also. So in the case of Shell's versus washer, which one would be easier? Well, I think Shell's clearly has the advantage here. If you look and I look at y equal x squared, rotating that around using Shell's method is pretty easy to set up the integral. So if I set up the integral using Shell's, it's the volume. The integral goes from 0 to 1 of 2 pi times the shell radius times the shell height. And it's the shell height part of this equation that makes the problem pretty easy. So 0 to 1, because my rectangles can be anywhere on the region from 0 to 1. So I'm inside this area. And we have to answer the question about what our radius is. And this is the sneaky part of this problem. Typically when we think of radius, we think of it as the distance from the axis of rotation to our rectangle. So if this red rectangle here was the rectangle we were looking at, the axis of rotation distance to that rectangle would be this distance that I've denoted with the green arrow here. That distance is the distance 1 for that piece plus whatever this function is as a function of y, which turns out to be square root of y. So looking at everything that's involved there, this could get kind of interesting because basically I'm going to place my rectangle anywhere along x, where x ranges from 0 to 1, and the shell radius is 1 plus that amount. So if I'm putting all of this together, then my shell radius is 1 plus x, and my shell height is, we just got through saying, y equal x squared or x equal to square root of y. It's y equal x squared is the appropriate piece to use for the height there, dx. So that's shell. I'd be ready to go at that point. If I used washer to complete this problem, then you can see this is going to be a little bit more difficult. The volume here is the integral from what to what? Well, if I'm integrating, think of the green rectangle here, it can be anywhere from 0 up to 1, because that's where my Horizontal lines that's where horizontal cuts can be made, starting from y equal to 0 all the way up to y equal to 1. And it would be pi times, I've got the radius of the outside minus the radius of the inside. So go back and review our washer video if you're having a little bit of trouble with that. And I would be integrating with respect to y here because I'm making horizontal cuts. Well, what is the radius of the outside? Well, the radius of the outside is 1 plus another 1. If you look, the outer radius is always a distance of 2 away from the axis. So the outer radius is 2, and the inner radius is always a distance of 1 plus some x. In other words, the x being square root of y in this case, or y equal x squared. Well, since I'm integrating with respect to y, I need to write this as the square root of y squared. And I forgot something really important here. I can't forget I'm adding on a distance of 1 all the time. So this would actually be minus 1 plus the square root of y squared. So this is the tricky part. This distance that my inner radius is going to take up is 1 plus the square root of y in that case, and up here on shells it was 1 plus x. So you have to be very, very careful about that particular part of this problem. So looking at these, I would say this is definitely, Shell's method is definitely the easier of the two. When you start to compare the two, setting them up is about the same difficulty, so it's not that much more difficult to set up the washer problem than it is the shells problem. But the shells problem is much easier to integrate. If you look at that, you don't have to worry about foiling this term out, and that makes it considerably easier to actually apply in this case if I wanted to find an answer. I'm not super interested in us doing that, but just for your benefit later, go ahead and test out both of these and see if in both cases you don't get a volume of 7 pi 6, which is actually the correct answer here. So go ahead and work out both of these integrals and check that you do indeed get 7 pi 6 for an answer. That way you'll know that you're doing this right. But if you're having any questions or any problems trying to set up volumes involving shells or washer method, especially around an axis of rotation like this that was x equal to -1, then I would encourage you to go back and look at shells and washer method and then see if you can't redraw the picture a couple times to get a better handle on it. All right, thank you for watching.